Okay, so today in this lesson, we are going to be making the change, going from expressions into equations. We're going to talk more about what that means in the coming days. Our focus is not going to be on equations or any of that stuff. We're just going to do what they call an anchor problem. This anchor problem leads into the whole rest of the chapter where we're dealing with equations. It is 1.0 anchor problem on chocolate. The directions are, I'm just going to summarize, we've got three situations. Two on the front and one on the back. I'm hoping we can get through the first and second situations today. If not, we'll just see how it goes. We'll maybe do another video. For sure, we're going to do the third situation in a different video, but let's see what we can get through today. We're going to read through each situation and we are going to model it in some way, shape, or form. Here are some things you can do to model it. You can do pictures. I really like the picture idea. Models, kind of the same thing. Like models would be like algebra tiles. You can kind of see I've already got something set up. They're not the traditional algebra tiles, but I've got something set up. So what I'm going to do is probably a mixture of picture or model, but you can also do equations. But I want you to go through each situation talking about or showing your work in some way, shape, or form to answer the question. Here is the first situation, and we're going to focus on this one all together as a class. Two students. Their names are Theo and Lance. They each have some chocolates. They know that they have the same number of chocolates. Theo has 4 full bags of chocolates and 5 loose chocolates. Lance, who does have the same amount as Theo, they have the same number of chocolates. Lance has it in a different version. Lance has 2 full bags of chocolates and 29 loose chocolates. What you need to do is determine how many chocolates are in a bag so that you can then use that information to figure out the number of chocolates that each child has. So if you're struggling to get started, we have practiced a lot modeling problems like this using algebra tiles. Maybe you can model the information with that same idea. Maybe you're ready to write equations. I want you to work with your groups. We're going to pause the video so that you can give yourself a chance to think about it. Ready, set, go. Okay, as I walked around the room, I saw a bunch of things. Here's what I saw the most. Some version of a picture model. There was also a good chunk of you who decided to write it mathematically or abstractly, and I like that. We'll talk about that in a second. But what does Theo have? I'm going to organize my information. Here's Theo on this side. What does Theo have? Jada. Very good. So do you see my symbols that I already have prepared here? What do you think I'm going to use for 4 bags? Probably 4 of these circles. And is that the only thing that Theo has? No, what else does he have? 5 of these loose ones. All right, what does Lance have? Emily? 2 bags, so let's pull out those 2 bags. And what else does Lance have? Is that all? 29 loose chocolates. I am gonna cheat and draw it with technology. You're only upset because you're jealous. All right. And what is the one thing that we know about them? They have the same amount. So somehow Theo's 4 bags and 5 extra chocolates ends up being the same as Lance's 2 bags and 29 chocolates. What? How does that work? They are the same. How do we use that information to figure out how many chocolates are in a bag? We're going to pause the recording as you guys think about that. How do we use this to figure out how much chocolate is in a bag? Kaden. Nope. We don't add 29 and 5. It doesn't say that this added together is this. It says this is somehow equal to this. So what do I do? Brighton. Okay, exactly. Will you take a look and see how these 5 chocolates, aren't they the same as these 5 chocolates? So obviously that's the same. Gone. What else is the same? Do you see how this bag is going to match that bag? And this bag is going to match that bag? So let's focus on this part then. We have 2 bags of chocolate that's somehow equal to 24 chocolates. How many chocolates would need to be in each bag? Allie? No? Because if there's only 5 in a bag, that's going to be 5 in one bag, that's going to be 5 in another bag, and why do I have all these extra loose chocolates? Marley? It would be 12, so here's another 5 for that bag, another 5 for that bag, and now 2 in that bag, and 2 in that bag. So, how many chocolates, how many loose chocolates of Lance's match one bag of Theo's? 12. One bag is equal to 12 chocolates, 12 loose chocolates. Yes, Jada. And now you realize, wow, that was really easy. I could have done that just fine, huh? Now we're going to do this one more time using equations. Let's do this with an equation now. What does Theo have? 4 bags. I'm going to represent that with 4B for bags. 1, 2, 3, 4, 5, plus 5 extra loose chocolates. And this is equal to and balanced with on the other side. Bryn. Yes, only I'm going to use B instead of X, but 2B for bags plus 29 loose chocolates. And look at that, we have an equation. How are we going to do this with the equation instead of the model? Well, what did we do? We were like, hey, those 2 bags are the same as his 2 bags. Let's just get rid of them. 4 bags minus 2 bags, that left us with 2 bags of Theo's, plus 5 loose chocolates, which is somehow equal to 29 loose chocolates. And we're like, wait a second, they both have 5 loose chocolates. Let's get rid of those 5 loose chocolates. And now we have 2 bags is equal to 24 loose chocolates. Oh no, what are we going to do now? Oh, we just simply split all of those chocolates into 2, so we know that one bag has 12 chocolates. So we can do this in a model, which makes it more quantitative. We can also represent it abstractly. And for your homework, I want you to look at situation 2. See how you can at least represent it. How are we going to represent it? How can we draw a picture of it? We'll go over this in our next lesson. Thanks for watching. We'll see you next time.